Hello, today we have come with a very easy question and solution of GATE 2024. This question is from Ordinary Differential Equation. Already we have solved some question of 2025 GATE and you can check the playlist. Now the question is, if x square y double dash minus 2x y dash plus 2y equal to 0, where x belongs to closed interval 1 2, and with the conditions y1 minus y dash 1 equal to 1, y2 minus k y dash 2 equal to 4, and this system has infinitely many distinct solutions, then we have to find the value of k. That is, for which value of k this system has infinitely many solutions. So let's start the solution. Since this is a very easy question of Cauchy-Euler method. Okay, so for finding the value of k, we have to solve this equation. For Cauchy-Euler, you know that we have to take x equal to e power z, that is z equals to ln x. And then if we take d as ddx and d1 as ddz, you know that these are all operators. Then the given question x square y double dash, that is d2y dx2 minus 2x dy dx plus 2y equal to 0, the given problem will be transferred to d2y dz2 minus dy dz minus 2 dy dz plus 2y equal to 0. Why? Because we know that if we take x equal to e power z, then our xd will be transferred to d1 and x square d2 will be transferred to d1 with d1 minus 1 multiplied. Okay, hence if we solve this, then we have d2y dz2 minus 3 dy dz plus 2y equal to 0. Now if we take y equal to a e to the power mz be the trial solution, then from the above equation we have m square minus 3m plus 2 equal to 0. And if we solve this, then we will have m minus 1, m minus 2 equal to 0. That is, the value of m will be 1 and 2. So hence we can write the solution in terms of z, because we have taken x equal to e power z. So the solution is c1 e power z plus c2 e power 2z, where c1 and c2 are arbitrary constants. And in terms of x, the solution will be yx equal to c1x plus c2x square, because x equal to e power z we already taken, and y dash x will be c1 plus 2 c2x. Now since we have the values of y1 minus y dash 1 equal to k and y2 minus k y dash 2 equal to 4, we will substitute these values. So y1 minus y dash 1 equal to 1. Hence, if we substitute 1 in place of x, then we will have c1 plus c2 minus c1 minus 2c2 equal to 1. Then c1 and minus c1 will be cancelled out. So, we will left with minus c2 equal to 1, that is c2 equal to minus 1. Now, for the second case, y2 minus k y dash 2 equal to 4. Then, substituting the values, we have 2c1 plus 4c2 minus kc1 minus 4kc2 or c2k equal to 4. Then 2c1, because c2 equal to minus 1, we can write 2c1 minus 4c2 minus kc1 minus and plus 4c2 equal to 4. Hence, since 4c2 and minus 4c2 will be cancelled out, so we can write c1 into 2 minus k equal to 4. Now, the question is given that the system has infinitely many distinct solutions. So since we have already the value of C2 equal to minus 1 and yx equal to C1x plus C2x square, then if we put C2 equal to minus 1, we are left with only C1x minus x square. So the system will have infinitely many solutions if we know that C1 is undefined. So we need such K such that C1 is undefined. Then we can say that the system has infinitely many solutions. And this is possible only when K equal to 2. Why? Because if K equal to 2, then the LHS will be 0, but the RHS is 4. So then we can say C1 is undefined. And then the final answer is K equal to 2.